Welcome. So today we will start another topic which is on conductance in electrolytic solution. So first let me tell you what to mean by electrolyte. So here electrolyte definition is given that these are those substances which when dissolved in solution get converted into ions. ये वो सब्सटेंस होते हैं जिनको हम जब डिजोल्व करते हैं सोल्यूशन के अंदर तो वो आयंस में कन्वर्ट होते हैं. तो आपके जो आयंस होंगे वो अगर पॉजिटिव आयन है तो उनको हम कटायन बोलेंगे, अगर नेगेटिव है तो अनायन बोलेंगे. जैसे कि आपका NaCl इलेक्ट्रोलाइट है तो Na+ जो है वो कटायन होगा और आपका Cl- जो है वो कटायन होगा. इसके अलावा हम जानते हैं जैसे हमारे पास आप देख सकते हैं कि कंडक्टर्स हैं. कंडक्टर्स के अंदर जो होती है जो चार्ज फ्लो होता है एक पॉइंट से दूसरे पॉइंट में वो इलेक्ट्रॉन्स कैरी करते हैं. ठीक है, इन कंडक्टर्स electrons carry charge from one point to the another, whereas in electrolytic solution it's the ions which are carrying the charge from one point to the other. So I will show in a while that in an electrolytic cell we will see that these are the ions which will carry charge from one point to the another, which is whereas in conductor it's the electrons which are responsible to carry the charge from one point to the other. Okay, now there is a term which is known as conductance. This way we must know the meaning because the whole chapter is dealing with this term only. So conductance means ease of flow of charge from one point to other. कितनी आसानी से चार्ज फ्लो हो सकता है एक पॉइंट से दूसरे पॉइंट पर किसी भी इलेक्ट्रोलाइटिक सोल्यूशन में. ठीक है, so conductance is the ease of flow charge from one point to another in any electronic solution. So I can write here that any electrolytic सोल्यूशन. सो कंडक्टेंस क्या है, कितनी आसानी से जो है चार्ज फ्लो हो सकता है एक पॉइंट से दूसरे पॉइंट पे इन एनी इलेक्ट्रोलाइटिक सॉल्यूशन इज नोन एज कंडक्टेंस. नाउ हियर आई हैव ड्रॉन इलेक्ट्रोलाइटिक सेल. सो हियर यू कैन सी दैट दिस इज वन इलेक्ट्रोड दिस इज कनेक्टेड टू पॉजिटिव टर्मिनल, so it will be called as anode. This is another platinum electrode which is connected to negative terminal, that will be called cathode. So we know that anode is electrode through which an ion will move, and cathode is electrode towards which cation will move. I am again repeating, anode is electrode towards which an ion will move, and cathode is electrode towards which the cation will move. So here we can see that when the electricity will pass through this solution, Na+ will move towards the cathode and that Cl will move towards the anode. So since these ions are moving, so these are carrying the charge from one point to the other. So that's why we say that in electrolytic solution the ions which carry the charge from one point to another. Now these two platinum electrodes are shown. So I've shown their area as A. So this is the area of the electrodes, and distance between these two electrodes I have denoted by L. You can see here the distance between the two electrodes I have denoted by L. Now very important here to learn is that what are the factors which are responsible. Now we know the conductance, that is कितनी आसानी से चार्ज जो है इलेक्ट्रोलाइट्स में फ्लो कर सकता है उसे हम कंडक्टेंस कहते हैं. तो now first we must know what are the factors which affect the conductance of electrolytes. So conductance of electrolytes first depends on nature of electrolyte. So whether we have strong electrolyte or we are making use of weak electrolyte. So strong electrolyte, as we know that these dissociate completely into the solution. So these get dissociated completely into the solution. So example are sodium hydroxide, potassium hydroxide, HCl. Here we can see the HNO3 there, phosphoric acid is there. Now since this get completely dissociated into solution, then we will have more number of ions. So we will have more number of ions, and then the conductance will be higher in case of strong electrolytes. Whereas in case of weak electrolytes, we know that the weak electrolytes are those which get dissociated to a very small extent. So there will be less number of ions, so conductance will be lower in this case. So conductance will be lower in case of weak electrolytes, conductance will be higher in case of strong electrolytes. Weak electrolytes example is acetic acid and oxalic acid. Here I have written. Now coming to second factor, which is size of ions. So we know that if the size of the ions is large, then obvious that they will move slowly. Yeah, so something is larger, then obvious that will move slow. And then if you have small ions, they will move faster, so the conductance will be higher for the small ions and conductance will be lower for the large ions. So here I can write that conductance will be lower here, and here conductance will be higher. Okay, this is the second factor. Then coming to distance between the electrodes. So जैसे जैसे distance between दोनों electrodes का बढ़ेगा वैसे वैसे conductance घटेगी. तो ease of flow of ions जो है वो आपका और ease of flow of charge है वो आपका स्लो होगा. तो इसके लिए हम कहेंगे कि डिस्टेंस ऑफ इलेक्ट्रोड्स अगर बढ़ता है तो आपका कंडक्टेंस जो है वो घटता है. तो C is inversely proportional to L. I have written here C is inversely proportional to L. Then coming to area of electrodes. जैसे एरिया बढ़ेगा वैसे ही कंडक्टेंस बढ़ेगा, क्योंकि more ions will be then striking to the electrode. So more ions will be striking to the electron, so conductance will be higher in this case. So if area of electrode is increased, then conductance will increase by this equation. Such as so we know that conductance is here is directly proportional to the area of the electrode. Area of the electrode, sorry, not electrode, area of the electrodes. So conductance is directly proportional to the area of the electrodes. Now another point is temperature, very important point. We know that when the temperature of the electrolyte will increase, so there will be more dissociation of ions. Dissociation of ions will increase. ठीक है, दिस विल इंक्रीज द वेलोसिटी ऑफ आयंस एंड दिस हेंस द conductance will also conductance will also increase. So since we are increasing the temperature, we always that viscosity will decrease, and also then which will again increase the conductance. So what is the influence, what is the effect of temperature? With increase in the temperature of the electrolyte, the conductance of the solution increases. Why? Because there is more dissociation of ions, velocity of the ions will increase, viscosity will decrease, and hence the conductance will increase. Very very simple. Then next is कंसंट्रेशन ऑफ सॉल्यूशन. तो जैसे जैसे कंसंट्रेशन बढ़ता है तो आयनिक इंटरफेरेंस जो है वो बढ़ता है बिटवीन द आयंस और अमंग द आयंस, इसलिए जो आपका कंडक्टेंस है वो डिक्रीज होता है. वेरी वेरी इंपॉर्टेंट पॉइंट. सो you know that when we have electrolyte in a solution, we have Na plus Cl minus, so there occurs interference among these ions also. So one ion can affect the other ion, the movement of the another ion. But if you diluting the sample, then the ionic interference between the ions or among the ions will be lower. But if you are concentrating the solution, then ionic interference among the ions or between the ions will be higher, hence the conductance will be lower. So conductance is lower when you are concentrating the solution, and conductance will be higher when you are diluting the solution. So with dilution, ionic interference decreases and hence the conductance increases. Ionic interference decrease हो जाता है और conductance आपका increase हो जाता है. ठीक है, तो अगर मैं यहाँ पे इक्वेशन की तरह मैं आपको सुना, मैंने अगर दो चीजें ले ली हैं, आपका कंडक्टेंस जो है डायरेक्टली प्रोपोर्शनल टू एरिया ऑफ इलेक्ट्रोड होता है और इनवर्सली प्रोपोर्शनल टू द लेंथ ऑफ द लेंथ और द डिस्टेंस बिटवीन द इलेक्ट्रोड. इनवर्सली प्रोपोर्शनल, सो मोर विल बी द डिस्टेंस बिटवीन द इलेक्ट्रोड्स, लोअर विल बी द कंडक्टेंस. सो combining these two, we have conductance is directly proportional to A by L. So whenever we are removing the directly proportionality constant, so we have to apply a constant which is here is K. So K is nothing but the specific conductance or conductivity. A is area of electrode, L is the distance between electrodes. So C is equal to Ka by L. This is very simple. So we have combined the two equation, and then K is the specific conductance or conductivity. Okay, now if I want to define K, how will you define K? So if you put, as we used to define any constant, the way we are defining that, one is we can put L equal to 1 centimeter and A equal to 1 centimeter square. So this is covering volume equal to 1 centimeter cube, and 1 centimeter cube is nothing but the 1 ml. So we can say simply that K or the conductivity is the conductance given by 1 ml of the solution. What is that? That is the specific conduction or conductivity, the conductance produced by 1 ml of solution. So here is the conductance produced by 1 ml solution. 1 ml solution or 1 cc of solution, that is 1 cubic centimeter of solution, or per unit volume of solution, any way we can define it. So we can have it 1 ml solution, any per unit volume of any solution, that is known as specific conductance or conductivity. Okay, so the conductance produced by 1 ml of the solution. Now for any cell, we can keep the distance between the electrode as constant, also the area of the electrode as constant. So L by A will be called as cell constant. L by A is called as the cell constant. For each and every cell, we can have the value of cell constant. Most of the time it will be there on the label. So the cell constant is fixed for a cell, and then electrolyte can be changed. So cell constant, if we are denoting by x, then A by L will become 1 by cell constant, that will be equal to 1 by x. So here it is 1 by x. Okay, then so if we put in the value, that is C equal to K A by L we have written, so here it will become C equal to K by X, because and now X is the cell constant. It's very very easy that you can now see that C equal to K by X. So before going further, we have to know the unit of these three terms. One is the conductivity or specific conductance, X is the cell constant, and C is the conductance. So conductance has been known with the reciprocal of resistance, everybody knows. So the resistance, the unit is ohm, so conductance unit will be ohm inverse. Ohm inverse can also be written as mho, mho, or mho, it is also called Siemens. So conductance unit is also Siemens. Okay, then coming to cell constant. Cell constant, I've told you, this is L by A, so centimeter by centimeter square, so it will be centimeter inverse. Then if the dimensions are taken in meter, then it will be meter inverse. Mm inverse, very simple. So centimeter inverse is the unit of cell constant. Then how to arrive at the unit of specific conductance or conductivity? So here you can see that it is centimeter inverse, so conductance is Siemens. So Siemens centimeter inverse will be the unit of conductivity or specific conductance, also can be written as ohm inverse centimeter. Okay, so this way we now know the unit of K, X and C. Then coming to another term, which is that is molar conductance. So remember that the name indicated defined as the conductance of solution having 1 mole of electrolyte, written as lambda molar. So here you have written that lambda molar if you are writing, so this is a molar conductance. उस सोल्यूशन की कंडक्टेंस जिसमें 1 मोल इलेक्ट्रोलाइट है उसे हम मोलर कंडक्टेंस कहते हैं, 1 मोल इलेक्ट्रोलाइट. ठीक है, तो इसके बाद हमें डिराइव करना होता है रिलेशन बिटवीन मोलर कंडक्टेंस एंड स्पेसिफिक कंडक्टेंस. कि मोलर कंडक्टेंस और स्पेसिफिक कंडक्टेंस क्या रिलेशन है, इसको ड्राइव करना बड़ा आसान है। अब देखिए, अगर मान लो हमारे पास कोई सोल्यूशन है जिसकी मोलरिटी हमें एम दी हुई है, ठीक है, वी हैव गिवन ए सोल्यूशन और जिसकी मोलरिटी हमारी एम है, तो हम जानेंगे कि एम मोल्स ऑफ इलेक्ट्रोलाइट जो है आपके 1 लीटर सोल्यूशन में होती है, ये मोलरिटी की डेफिनेशन होती है। इसका मतलब अगर किसी सोल्यूशन की मोलरिटी एम है, इसका मतलब एम मोल्स जो है इलेक्ट्रोलाइट के 1 लीटर सोल्यूशन में डिजोल्व है। तो हम जानना चाहते हैं 1 मोल इलेक्ट्रोलाइट किसमें कितने सोल्यूशन में डिजोल्व होंगे, तो ये होंगे 1000 बाई एम एम एल सोल्यूशन, ठीक है। 1 मोल इलेक्ट्रोलाइट किसमें होंगे, 1000 बाई एम एम एल सोल्यूशन में डिजोल्व होंगे। और हमें पता है कि जो कंडक्टिविटी होती है 1 एम एल सोल्यूशन की, वो स्पेसिफिक कंडक्टिविटी ही होती है, जिसे हम कंडक्टेंस कहते हैं, कंडक्टिविटी कहते हैं। तो 1 एम एल इलेक्ट्रोलाइटिक सोल्यूशन की जो कंडक्टिविटी होती है या कंडक्टेंस होती है, उसे हम स्पेसिफिक कंडक्टेंस और या फिर कंडक्टिविटी कहते हैं। तो इतने एम की, जैसे 1000 बाई एम एम एल निकाला जो कि 1 मोल इलेक्ट्रोलाइट कंटेन कर रहा है, तो उसकी कनेक्टिविटी हो जाएगी आपको 1000 बाई एम इंटू के। अगर इसको हम लिख देंगे लैम्डा मोलर है। इस तरह से हमने डिफाइन ड्राइव कर दिया कि आपका जो मोलर कंडक्टेंस है, मोलर कंडक्टेंस और आपका जो स्पेसिफिक कंडक्टेंस है उसमें क्या रिलेशन है कि मोलर कंडक्टेंस इज इक्वल टू 1000 इंटू स्पेसिफिक कंडक्टेंस डिवाइडेड बाय मोलर। तो स्पेसिफिक कंडक्टेंस और द conductivity we can call it, so here yes, conductivity to be taken in Simon centimeter inverse, ठीक है, this always to be taken in Simon centimeter inverse. Why? Because if you are taking in Simon meter cube meter inverse, then the value will be different. How? So here I have written that kappa Simon meter inverse is equal to kappa sin when taken in unit Simon centimeter into 10 power 6. Yeah, why? Because 1 meter cube is equal to is occupying how much 1000 liter of water or solution. ठीक है, so 1 meter cube is equal to 1000 liter of water or solution, so it will be 10 power 6 centimeter cube. It will be 10 power 6 centimeter cube. So if I want to put this value centimeter Simon inverse, you put in here value, so here it will become kappa Simon meter inverse divided by 10 power 6. This will go, so your molar conductance will become equal to the specific conductance divided by 1000 into m. So here the specific conductance is taken in Simon meter inverse, ठीक है। So this unit is very important. So if unit is given in Simon meter inverse, you will apply this formula. If the unit of specific conductance is given as Simon meter inverse, you will apply this Simon centimeter inverse, then you will apply this formula, that is molar conductance 2000 into specific conductance divided by molarity. Okay, now we want to know the unit of molar conductance, so then we can apply this formula k into 1000 by m. K unit is as Simon centimeter inverse, molar unit is molar per liter, so liter can be written as 1000 ml, so 1000 can be, because it is a constant, so mol ml minus inverse, so ml is nothing but a centimeter cube, so I will put here minus 3. So above centimeter inverse is there, so your unit will become Simon centimeter square mole inverse. So this is the unit of molar conductance. Okay. What is the unit of molar conductance? It is Simon centimeter square mole inverse. Similarly, there is another term which is known as the equivalent conductance. Equivalent conductance, if you want to define, it is defined as the conductance produced by 1 gram 1 gram equivalent of electrolyte. It's known as equivalent conductance. It's the conductance produced by 1 gram equivalent of the electrolyte, that is known as equivalent conductance. So formula can be only here m will be replaced by n, so k into 1000 by n, so your unit will become Simon centimeter inverse equivalent inverse. Equivalent inverse. So now you know the unit of all these: cell constant, conductance, conductance, molar conductance, and equivalent conductance. So remember that the unit of all these terms now you must know. Okay. So now the topic is effect of dilution on conductance. Okay, so next topic is effect of dilution on conductance, and very important law which is known as Coleridge law. So we will study very easy. So we know that we want to know that if you are diluting the electrolyte, then what will happen to conductance, what will happen to specific conductance, what will happen to molar conductance. So first take the case of conductance. So when we are diluting the electrolyte, then what will happen is that the ionic interference among the ions, or between the ions, if two ions are there between the ions, and among the ions will decrease. So if you are diluting the electrolyte, the ionic interference between the ions will get dissolved, so that will it decrease, and thereby conductance will increase. ठीक है, जैसे जैसे हम सोल्यूशन को डाइल्यूट करते हैं तो जो आपका आयनिक इंटरफेरेंस है अमंग द आयंस वो डिक्रीज होता है और आपका जो कंडक्टेंस है वो आपकी इंक्रीज होती है. ठीक है, तो इसलिए क्या होगा कि सिंपल कि आप डाइल्यूशन कर रहे हैं इलेक्ट्रोलाइट का तो आपका कंडक्टेंस जो है वो इंक्रीज होगा. बात करें स्पेसिफिक कंडक्टेंस की. स्पेसिफिक कंडक्टेंस मैंने आपको बताया था कि वो कंडक्टेंस, स्पेसिफिक कंडक्टेंस वो कंडक्टेंस होती है जो कि प्रोड्यूस की जाती है 1 ml इलेक्ट्रोलाइट सोल्यूशन के द्वारा. तो अब 1 ml में जब हम डाइल्यूट करेंगे तो आयंस जो है कम मात्रा में रह जाएंगे. ठीक है, देयर विल फ्यूअर नंबर ऑफ आयंस 1 ml ऑफ सोल्यूशन. So then what will happen? The specific conductance will decrease. ठीक है. So since ions are fewer, so specific conductance will decrease. So remember that with increase in dilution, the specific conductance decreases, conductance increases. Then coming to molar conductance. Molar conductance means what? It is the conductance which is produced by solution containing 1 mole of electrolyte. The conductance which is produced by solution containing 1 mole of electrolyte. So if you are diluting the sample, what will happen is that 1 mole of electrolyte will occupy more solution. Okay, so simple. If you're diluting the sample, if we want to have 1 mole electrolyte, then it will occupy more solution. So then what will happen? Ionic interference will decrease, and thereby molar conductance will increase. So remember, with dilution, conductance and molar conductance both increases, whereas specific conductance decreases. So this is the point which I wanted to see. Okay, now since we are diluting the sample, so your conductance, molar conductance is increasing. There will be particular dilution, or that we call it zero concentration. What will happen is that here molar conductance here will become maximum. मोलर कंडक्शन आपकी मैक्सिमम हो जाएगी, और उस कंडक्टेंस को हम कहेंगे लिमिटिंग मोलर कंडक्टेंस. उस कंडक्टेंस को हम क्या बोलेंगे? लिमिटिंग मोलर कंडक्टेंस, जिसका दूसरा नाम बोलते हैं मोलर कंडक्टेंस एंड इनफिनिट डाइल्यूशन, तीसरा बोलते हैं मोलर कंडक्टेंस एंड जीरो कंसंट्रेशन. ऑल द थ्री टर्म्स आर द सेम. ठीक है. So if you are diluting the sample, there will be a point at which the molar conductance will be maximum, and that point will be called as limiting molar conductance and infinite dilution, molar conductance zero concentration. Okay. So if you want to draw if we draw a graph between the square root of the concentration and also the molar conductance. So here in the axis I have taken square root of concentration. So this way concentration is there increasing, and this way on the opposite side dilution is increasing, and on the y axis I have taken molar conductance using the Siemens inter inverse mole inverse. Okay. So now here this line I have shown, this line you can see, this line is for the strong electrolyte, this line is for the strong electrolyte. So as the dilution is increasing, so dilution is increasing towards zero. So dilution, as the dilution is your molar conductance is increasing, and this molar conductance, so here we can see that it is, by extrapolating we can see that at infinite dilution it will be meeting the y-axis. So this point is known as the concentration, that is molar conductance at infinite dilution or molar conductance at zero concentration. Okay, so for strong electrolytes we can very easily calculate the molar conductance at infinite dilution. But for weak electrolytes, we have the graph which is shown here. So this is weak electrolyte, you can see. So this is weak electrolytes. So this is graph for weak electrolytes. So weak electrolytes graph is like more or less like hyperbola, and here we can see that the graph is not touching the y-axis anywhere. So we say that it is very difficult to determine the molar conductance of weak electrolyte. So example of weak electrolyte is acetic acid, oxalic acid, and strong electrolytes here are shown NaCl, KCl, HCl. Okay. So this graph is to explain the Coleridge law. So you can draw this graph in case of Coleridge law also. So we will now define the Coleridge law here. So here we can see that what is the Coleridge law? So at infinite dilution, that is at infinite dilution, or we call it limiting molar conductance, or molar conductance and infinite dilution, molar conductance at zero concentration. So what will happen, as we know that infinite dilution, the dilution is increasing, the cations or anions are behaving independent to each other. So their molar conductance will be, molar conductance of cations and anions are independent of each other. That's the meaning. What is the meaning? That limiting molar conductivity of any electrolyte can be represented by sum of individual contribution of cations and anions of the electrolyte. Okay? So if we have Na solution in and I want to determine the molar conductance at infinite dilution of NaCl, then that will be equal to the molar conductance of Na plus at infinite dilution प्लस मोलर कंडक्टेंस ऑफ क्लोराइडेंस एट इनफिनिट डाइल्यूशन. दोनों को सम कर देंगे क्योंकि अब दोनों ये इंडिपेंडेंट है, दोनों के बीच में आयनिक इंटरफेरेंस नहीं रह गया डाइल्यूशन की वजह से, इनफिनिट डाइल्यूशन है. तो आपका जो है इन दोनों का समीशन ही आपका मोलर कंडक्टेंस इलेक्ट्रोलाइट का निकल आएगा. ठीक है. तो स्ट्रॉन्ग इलेक्ट्रोलाइट का हम आसानी से मोलर कंडक्टेंस जो है निकाल पाएंगे. उसी तरह से अगर हमें इक्विवेलेंट कंडक्टेंस निकालना है NaCl का, तो आप उसको इक्विवेलेंट conductance at infinite dilution for sodium ion, equivalent conductance of chloride at infinite dilution, दोनों को ऐड कर देंगे तो आपका जो है equivalent conductance NaCl का infinite dilution पे निकल आएगा. ठीक है. ये तो हो गया आपका स्ट्रॉन्ग इलेक्ट्रोलाइट्स का निकालने का तरीका. दूसरा जो है हम कोलरिज लॉ से वीक इलेक्ट्रोलाइट की कंडक्टेंस को भी पता लगा सकते हैं. वो कैसे? जैसे मान लो मुझे वीक हमारे पास एसिटिक एसिड है, उसका मुझे मोलर कंडक्टेंस निकालनी है. जैसे मैंने यहाँ पे लिख दिया मोलर. ठीक है. तो ऐसे ये सब जो है आपकी मोलर हो जाएंगी सारी, ये आपकी मोलर हो गई. ठीक है। तो एसिटिक एसिड की अगर मुझे मोलर कंडक्टेंस निकालनी है इनफिनिट डिल्यूशन पे, तो मैं क्या करूँगा, सोडियम एसिड की इनफिनिट डिल्यूशन पे मोलर कंडक्टेंस का पता लगा लूँगा, क्योंकि ये आपका स्ट्रॉन्ग इलेक्ट्रोलाइट है। HCl का हम निकाल लेंगे मोलर कंडक्टेंस इनफिनिट डिल्यूशन की, ये भी स्ट्रॉन्ग इलेक्ट्रोलाइट है। NaCl की भी हम मोलर कंडक्टेंस निकाल लेंगे इनफिनिट डिल्यूशन। अब देखिए, अब एसिटिक एसिड की, अब जब इन दोनों को ऐड करके, एसिटिक एसिड और HCl की ऐड करके मैं NaCl में से माइनस कर दूंगा, तो मेरे पास एसिटिक एसिड की मोलर कंडक्टेंस आ जाएगी। वो कैसे, ये आपको देखो, ये CH3CO माइनस दे रहा है, N प्लस दे रहा है, प्लस H प्लस दे रहा है, Cl माइनस दे रहा है, माइनस Na प्लस माइनस Cl माइनस, तो Na प्लस और Cl माइनस सब्ट्रैक्ट हो जाएगा, तो आपकी जो मोलर कंडक्टेंस वो बच जाएगी आपकी एसिटिक एसिड की। ठीक है। तो इस तरह से जैसे मैंने कहा था कि आपको हम ग्राफ से हम वीक इलेक्ट्रोलाइट की जो है मोलर कंडक्टेंस इनफिनिट डिल्यूशन पे नहीं निकाल सकते हैं ग्राफ से, तो इसलिए हम इस तरीके से कोलरिच लॉ का यूज़ करते हुए हम वीक इलेक्ट्रोलाइट की मोलर कंडक्टेंस को इनफिनिट डिल्यूशन पे बहुत ही आसानी से निकाल सकते हैं। ठीक है। एक और पॉइंट है कोलरिच लॉ में कि आपका हम इसके अलावा हम डिग्री ऑफ डिसोसिएशन भी निकाल सकते हैं वीक इलेक्ट्रोलाइट की। ठीक है। तो अगर मुझे डिग्री ऑफ डिसोसिएशन निकालनी है, तो उसका फॉर्मूला है कि आपके मोलर कंडक्टेंस जो है कंसंट्रेशन C पे मैं डिवाइड कर दूंगा मोलर कंडक्टेंस एट इनफिनिट डिल्यूशन, दिस द फार्मूला ऑफ डिग्री ऑफ डिसोसिएशन। So degree of dissociation for a weak electrolyte is the ratio of molar conductance at any concentration C to the molar conductance at infinite dilution the same electrolyte. Okay, so once we know the degree of dissociation, we can calculate the dissociation constant also, that is C alpha square by minus alpha. This I have told you in chemical equilibrium chapter. So this will be alpha equal to C molar conductance at concentration square divided by molar conductance at infinite dilution to the bracket molar conductance at infinite dilution minus molar conductance at any concentration. So this will be the final formula, that C into molar conductance at concentration C square divided by molar conductance at infinite dilution bracket में molar conductance at infinite dilution minus molar conductance at concentration C. So this will be your dissociation constant. So using Correlate's law, you can also calculate the dissociation constant. ठीक. So these are the points to be written in Correlate's law. I can again show you that at infinite dilution molar conductance of cations are independent to each other, and limiting molar conductivity of any electrode can be represented that sum of individual contribution of ions at cations of the electrolyte. So NaCl will be the sum of Na plus and Cl minus in dilution. Similarly, we can calculate the molar conductance at infinite dilution for weak acid or weak electrolytes, and we can calculate degree of dissociation also, and also the dissociation constant. Okay. चलिए अब हम स्टार्ट करते हैं इलेक्ट्रिकल कंडक्टेंस ऑफ मिल्क के बारे में। ठीक है। वी हैव स्टडीड टिल नाउ अबाउट द बेसिक्स ऑफ conductance, conductivity, that we have understood the concept of conductance and what factors the conductance of electrolyte solution depends, and what is the effect of dilution, also Correlate's law we have studied. Okay, now we will study some part of milk, that electrical conductance of milk we will study about. So first of all, let me tell you what is the electrical conductance of milk. Electrical conductance of milk ranges from 0.040 to 0.055 ohm inverse centimeter inverse at 25 degrees Celsius. So here it is written. Okay, so 0.0040 to 0.0055 ohm inverse centimeter inverse at 25 degrees Celsius. This is the electrical conductance of milk. So if you want to represent same in case in terms of Simon meter inverse, it is 0.460 Simon meter inverse. This is the conductance of milk. ठीक है. So electrical conductance of milk in terms of ohm inverse, centi inverse and Siemens meter inverse I have told you. ठीक है. Now one question which comes in, what are the factors or components which affect the conductance of milk? कौन से ऐसे factors हैं, ये components हैं जो कि conductance of milk को affect करते हैं, वो हमें अभी पढ़ने हैं. तो पहला जो फैक्टर है वो चार्ज स्पीसीज, जो आप हम जानते हैं देयर आर साल्ट्स व्हिच आर प्रेजेंट इन मिल्क. ठीक है. एंड since these salts will get converted into ions, so we have ions in the solution, sodium ion, potassium ion and chloride ions. These are the principal contributor to the electrical conductance of milk, because we know that conductance is due to ions only. So the major contributor to the conductance of milk is the ions, sodium ion, potassium ion, chloride ions. Okay. And here it is written that if we have NaCl solution which is having 0.1% chlorine, the same as that which is present in milk. Okay. Milk is also having 0.1% chlorine around, so that solution is showing conductance of 0.030 ohm inverse centimeter inverse. Okay, just to show that the ions are the major contributing factor to the electrical conductance of milk. So one is charge species, that is sodium ion, potassium ion, chloride ions. These are the major contributor to the electrical conductance of milk. Then second factor is lactose. So lactose is having little contribution, so it is not affecting, because this is a molecule that is non-ionic molecule. So lactose is having little contribution toward the electrical conduction of milk. But when it is fermented, you know that lactose will get converted to lactic acid, and these will then carry the this and will then conduct the electricity, so the electrical conductance will increase. only. So lactose when gets fermented, lactose get converted to lactic acid, so the electrical conductance will increase by the either by the action of microorganisms, it will happen, and you will have electrical conductance will increase. So lactose is having very little contribution as such. Lactose is having as very little contribution as such. Okay, so the next factor is casein or the proteins. So casein and protein, they are also having very small contribution to the electrical conductance of milk. But they only what they do is that the proteins hinder the movement of ions, that the conductance of milk, thereby decreasing the conductance of milk. So proteins, what they are doing, they are hindering the movement of the ions which I have shown, that sodium and potassium and chloride, which are different ions are there. So these proteins will hinder their movement, and since the movement is hindered, so there will be a decrease in conductance. Otherwise, if somebody asks you, casein and proteins is also having very small contribution towards the electrical conductance, and indirectly it is decreasing the electrical conductance of milk. There's a casein and protein. Then coming to fat, fat, you know that we have fat globules in milk, and which contribute to around 4 to 5% of total volume of milk. So fat globules covers the 4 to 5% of total volume of milk, and because of this fact, that 50% hindrance is there because of the fact that fat globules contribute or covers 4 to 5% total volume of milk, and another 50% hindrance is by actual obstruction of the ions. So their fat globules are obstructing the ions, they are not allowing the ions to flow easily, so your molar conductance or the conductance of milk will decrease. Okay, so that is why we said that here I have written in light that electrical conductance, this is specific conductance, or the conductivity of whole milk is lower than that of the skim milk by 10%. तो skim जो whole milk की जो conductivity होती है वो स्किम मिल्क से 10% कम होती है. क्यों कम होती है? क्योंकि होल मिल्क में हम जानते हैं कि आपके फैट ग्लोबुल्स हैं, और फैट ग्लोबुल्स का मैंने आपको बता दिया कि 4 to 5% टोटल वॉल्यूम ऑफ मिल्क कंट्रीब्यूट करते हैं, और आपका 50% हिंड्रेंस जो है वॉल्यूम ऑक्यूपेशन से होती है, और सेकंड 50% हिंड्रेंस जो होती है वो एक्चुअली ऑब्स्ट्रक्शन ऑफ द आयंस से होती है. ठीक है, सो होल मिल्क इज हैविंग इस कंडक्टिविटी ऑफ द होल मिल्क इज लोअर देन दैट ऑफ द स्किम मिल्क बाय 10%. Okay, then another factor which I have already told you when we covered the basics, that another topic is that point is temperature. ठीक है, so when we are increasing the temperature, viscosity of the milk will decrease, and hence the electrical conductance will by increase. ठीक है, so simple. So there will again I told you there will be increased dissociation of the salts, increased dissociation of the electrolytes, and also your viscosity will decrease, velocity of the ions will increase, thereby electrical conductance will increase. तो ऐसा देखा गया कि जो इलेक्ट्रिकल कंडक्टेंस है वो 0.001 ओम इनवर्स सेंटीमीटर इनवर्स से बढ़ जाती है पर पर 1 डिग्री सेल्सियस टेम्परेचर. अगर मैं 1 डिग्री सेल्सियस टेम्परेचर किसी सोल्यूशन का या मिल्क का बढ़ाता हूँ तो कितनी इंक्रीज होती है? 0.001 ओम इनवर्स सेंटीमीटर इनवर्स जो है आपकी जो है इलेक्ट्रिकल कंडक्टेंस जो है वो इंक्रीज होती है. ठीक है, दैट इज द 2% इलेक्ट्रिकल कंडक्टेंस इंक्रीज होती है पर 1 डिग्री सेल्सियस इंक्रीज इन टेम्परेचर. अगर मैं 1 डिग्री सेल्सियस इंक्रीज करता हूँ टेम्परेचर को, तो जो इलेक्ट्रिकल कंडक्टेंस है वो आपकी 2% इंक्रीज होती है. दिस वी हैव टू रिमेंबर. दिस इज नेक्स्ट फैक्टर, दैट इज टेम्परेचर. Okay, now coming to dilution, as I already told you that when up to 30%, it has been observed that up to 30% SNF, ठीक है, in skim milk, what will happen is that electrical conductance will increase up to 30% SNF, and if the SNF is increasing greater than 30%, ठीक है, then conductance is decreasing. This is the known fact. And why it is decreasing? Because there will be repression of the ionization का रिप्रेशन हो जाता है. तो हम जानते हैं कि जैसे डाइल्यूशन होता है, आयोनिक इंटरफेरेंस जो है वो आपका कम होता है, तो इसलिए कंडक्टेंस बढ़ेगा, और अगर कंसंट्रेशन बढ़ेगी तो आपका जो आयोनिक इंटरफेरेंस है वो ज़्यादा होगा, तो कंडक्टेंस आपकी डिक्रीज होगी. तो 30% एसएनएफ तक स्किम मिल्क में मेनली. ठीक है, स्किम मिल्क में अगर हम देखें 30% एसएनएफ इंक्रीज करने तक तो इलेक्ट्रिकल कंडक्टेंस बढ़ती है, और अगर हम ग्रेटर देन 30% एसएनएफ लेके जाते हैं तो इलेक्ट्रिकल कंडक्टेंस जो है वो आपकी घटती है. ठीक है, सो दीज आर द फैक्टर्स और कंपोनेंट्स in milk which is affecting the electrical conductance of milk. So quickly we will know what is the application, why we are studying the electrical conductance of milk, and what are its application. So first is electrical conductance. The concept of electrical conductance of milk will help in detecting the subclinical mastitis. So we know that during mastitis what happens is that lactose and potassium decreases and sodium and chloride increases to preserve the osmolarity with the cow blood. So since blood has to be under isomolar condition with that of the milk, so since the lactose and potassium decreases, so sodium and chloride increases, which increase the conductance of milk. And by developing suitable models, we can able to detect the milk as submastatic milk. Okay, so submastatic milk we can easily detect because the conductance of the milk will increase because of the increase in the concentration of sodium and chloride ions. So ions which are contributing to the electrolyte conductance of milk, if they are increasing, then obvious that conductance will increase, and by developing suitable models we can detect a milk to be of subclinical mastatic milk. Okay, then second point is water adulteration. So I've told you that with dilution the conductance is increasing. That fact, if anyhow, could be used to detect the water adulteration. So some of the researchers have tried to explore this fact, but it has been concluded that the water adulteration cannot be used as using the electrical conductance. Why? Because conductivity among the milk varies. Okay, so since the conductivity among the milk varies, it's very difficult to detect the water adulteration in milk using the concept of electrical conductance. Okay, now another point is the detect neutralizers. So we can detect the neutralizers. It's obvious that if you are adding neutralizers, okay, but also neutralize sodium hydroxide, sodium bicarbonate, sodium carbonate. So these are neutralizers. So to neutralize the acidity in milk, if acidity is increased, so neutrals are being added. So if these neutralizers are being added, so these will be contributing to the ions, and hence the conductance will increase. And that conductance, by developing suitable models, we can detect the presence of neutralizers in milk by correlating the data which will be obtained between the concentration of the neutralizer and also the value of electrical conductance. We can able to detect the presence of neutralizers in milk. Okay, another point is growth of lab by conductometry method. So if you want to know the growth of lab, that number of microorganisms which are there, what is the quality of milk, by conductometry method, that also we can. So how? Because when lab grows, then it will attack on proteins, carbohydrates, fats, and there will be a big production of ionic molecules. Ionic molecules प्रोड्यूस होते हैं, तो लैब जो है प्रोटीन्स प्रोटीलिसिस होता है, कार्बोहाइड्रेट पे एक्ट होते हैं तो ग्लाइकोलिसिस होता है, फैट होता है तो आपका लाइपोलिसिस होता है. तो दीज आर द थ्री टर्म्स. व्हाट आर द थ्री टर्म आई एम राइटिंग हियर? प्रोटीन का अगर लैब प्रोटीलिसिस करते हैं और आप कार्बोहाइड्रेट का ग्लाइकोलिसिस करते हैं, ग्लाइकोलिसिस करते हैं और फैट का आपका लाइपोलिसिस करते हैं. ठीक है, तो आपका प्रोटीलिसिस, ग्लाइकोलिसिस और लाइपोलिसिस की वजह से आयनिक मॉलिक्यूल्स प्रोड्यूस होते हैं और इसकी वजह से कंडक्टिविटी इंक्रीज होती है. ठीक है, और दूसरा कारण ये है कि जैसा हमारा हम जानते हैं कि लैक्टिक एसिड हमारा प्रोड्यूस होता है जब लैब ग्रो होते हैं, तो उससे हमारी पीएच डिक्रीज होती है. तो पीएच डिक्रीज होने की वजह से जो आपका कोलोइडल फॉस्फेट है उससे कैल्शियम आयन जो है रिलीज हो जाता है, और हम जानते हैं कि कैल्शियम आयन रिलीज होगा तो कंडक्टेंस बढ़ जाती है. ठीक है, तो ये इक्वेशन मैं लिखता हूँ हमेशा 3 कैल्शियम आयन प्लस 2 फॉस्फेट आयन गिव्स यू कैल्शियम फॉस्फेट प्लस 2H प्लस आयन. सो इन दिस वे, in this direction, if the acidic conditions are there, then the reaction will move towards this direction. If basic conditions are there, then reaction will move towards this direction. Okay, so since pH is decreasing, so your reaction will proceed in the backward direction, so there will be more production of calcium ion from the colloidal phosphate, so your conductance will increase. Okay, so depending on the number of microorganisms are present, your conductance will increase, and that way we can determine the quality of milk. That way we can know the growth of microorganisms in milk. This is known as conductometry method to determine the growth of microorganisms or growth of lab by conductometry method. Okay, so I'm again repeating. So there are labs which are present, microorganisms which are present in milk. They're acting on protein, carbohydrate, and fat by proteolysis, glycolysis, and lipolysis. So there will production of ionic molecules. Conductance will increase. So conductance will be related to the number of organisms which are present in milk. And also another way is that since pH is getting reduced, your calcium will be coming out of the colloidal phosphate, and again that will also increase the conductance, and then that can be correlated with the number of microorganisms or the quality of milk. Okay, then fifth point is viscosity of milk. So I've already told you that viscosity is inversely proportional to the electrical conductivity. So indirectly we can also determine the viscosity of milk if we know the electrical conductivity of milk. ठीक है. So models, suitable models can be developed and we can determine the viscosity of milk as well. Okay, then last point which I want to share with you is that electrical conductance of stored whole milk is greater than stored skim milk. So I've told you that electrical conductance of whole milk is lower than that of the skim milk by 10%. I've told you just now, but here I've written that if you're storing the whole milk, then the electrical conductance increases. And why this is happening than compared to stored skim milk? Why? Because in whole milk we are having fat, so that fat when you are storing will get converted to free fatty acid. So free fatty acid, then these will be contributing to the ions, the electrical conductance will increase. And also, since from the fat globule membrane there will phosphate ions will also come from the fat globule membrane, which also will contribute to the electrical conductance, and therefore electrical conductance will increase. So that is why if somebody asks you why the electrical conductance of stored whole milk is greater than that of the stored skim milk, this is the reason that fat get converted to free fatty acid during storage because of the rancidity which occurs. That is by hydrolytic rancidity we call it hydrolytic rancidity. The fat will be get converted to free fatty acid, and your phosphate ions will be also contributing to the electrical conductance that will come from fat globule membrane. So with this your chapter is completed. Thank you.